When astronomers say Big Bang, they don't mean an explosion into space. They mean space itself began expanding. Imagine a stretchy grid. As the grid expands, every distant dot drifts away from every other. We know this because galaxies' light is redshifted. Its waves stretched as space expands, a discovery linked to Hubble and Lemaitre. The farther a galaxy is, the faster it recedes. That simple pattern reveals a universe that's growing. Rewind the clock and everything was closer, hotter, and denser, a young universe filled with brilliant plasma. In the first minutes, matter was a searing mix of particles. Atoms couldn't hold together yet. As it cooled, the universe forged its first elements, mostly hydrogen, some helium, and a trace of lithium. Many models include inflation, a split-second growth spurt that smoothed space and stretched tiny ripples huge. Those ripples were seeds, minuscule density bumps that gravity would later grow into galaxies. About 380,000 years in, electrons finally latched onto nuclei. Space turned transparent, light could travel. We still see that first light today as the cosmic microwave background, the CMB, a faint, nearly uniform glow. Satellites like WMAP and Planck mapped tiny temperature bumps in the CMB, the exact fingerprint of those early ripples. Invisible dark matter formed a cosmic web, its gravity guiding ordinary gas into lanes and intersections. Hundreds of millions of years later, the first stars lit up, reionizing the fog and beginning cosmic dawn. Over time, small galaxies collided and merged, building the giant spirals and ellipticals we see nearby. Even galaxy maps keep a memory of early sound waves, baryon acoustic oscillations, a preferred spacing frozen into structure. Only a small fraction is atoms. Dark matter and dark energy dominate the cosmic budget. Supernova studies showed expansion is speeding up, evidence for dark energy, a push woven into empty space. Piece these clues together, and the age emerges, about 13.8 billion years since the hot, dense beginning. New telescopes like JWST peer back to very early times, spotting compact, surprisingly bright young galaxies. Expansion is like rising dough. The raisins don't fly through bread. The bread itself stretches between them. Locally, gravity can beat expansion. Our Milky Way and Andromeda are actually on a slow-motion collision course. Redshift measures stretching directly. Spectral lines slide to longer wavelengths the farther their galaxy is. Instruments tuned to microwaves catch the CMB's whisper, just a few degrees above absolute zero. Gravity also bends light. Lensing lets astronomers weigh clusters and magnify very distant galaxies. Start with the CMB's tiny bumps, evolve with physics, and the result matches web-like structure we map today. Alongside light-raced neutrinos, ghostly particles from the first seconds. Hard to detect, but part of the story. Why anything remains is a big question. A tiny early imbalance favored matter over antimatter, and here we are. Out of simple beginnings came complexity, stars forging elements, planets forming, and chemistry waking into life. Science keeps testing. Expansion, light elements, and the CMB agree. Details of dark energy and early growth are active frontiers. Different telescopes, radio, microwave, infrared, optical, X-ray, combine to make one consistent timeline. Even the universe's exact expansion rate is being refined. Measurements don't all match yet, and that's exciting. The wonder remains simple. When you look up, you see ancient light on a journey that began near the beginning. Hydrogen from the beginning became the fuel of stars, and stars forged the ingredients for planets and people. When atoms formed and light broke free, the cosmic morning started. We're reading that sky-wide sunrise today. Clusters show dark matter's pull and trap hot gas, acting like laboratories for gravity and light. Over billions of years, galaxies grow and transform. Bars stir disks, mergers round them, and black holes flare. If acceleration persists, distant galaxies will fade from view, leaving island universes of neighbors. But tonight, the sky is full. Evidence written in starlight that we can test, question, and understand together. Expanding space, light elements, a baby picture sky, first stars, galaxies, and us. Each new image tightens the story, sometimes with surprises that sharpen our models and our curiosity. From the widest web down to a quiet shore, the same laws hum beneath everything we see. You don't need a giant observatory to join in. One sky, shared questions, and tools that fit in your hands. The Big Bang is our best map so far, a testable story that keeps inviting better questions. From a hot, dense beginning to an ever-growing universe, the adventure is still unfolding. Like, comment, and subscribe for more videos like this.